Hello, everybody. Welcome to another episode of the Greenlink Podcast, where we talk all things energy efficiency and renewable energy. Today, I have Ms. Barb Basaj with us here. She is Greenlink's Energy Auditor, among many other things. Barb wears many hats at Greenlink. Barb, thanks for coming on today.
You bet.
Look forward to talking today about your expertise in the building science arena. I know that you've been in it for many years, and I guess just jumping right in, I'd love to hear, and maybe you could share a little bit with us some of your background in the energy efficiency space. I know you were up in Wisconsin and focused on energy for many years, and then a couple years ago, you came to Greenlink. But maybe you could share with us a little bit about your background.
Yeah, so I actually started, before I became an energy auditor, I was a home inspector and a solar site assessor.
Okay.
And back in the day, a solar site assessor was a little different than what you guys do today.
When was that? Just out of curiosity, like year-wise?
2006 to 2012.
So you were early in the solar area doing solar site assessments.
Yeah,
Wow.
and it was more of a role where we were trying to guide the industry to sort of weed out the people who were kind of not exactly
good candidates, maybe.
No, well, there's that, but also there were some bad players in the industry.
Got it.
In the past, in the 70s, and people were gun shy about even jumping forward with solar.
Okay, gotcha.
So we needed site assessors to just kind of give people an unbiased perspective.
Yeah, that makes sense. So you guys were a neutral third-party organization,
right?
And you would kind of educate the homeowners on how solar would work for them and the viability based on, the trees and shade and things like that, I would imagine.
Yeah, and the financial calculations were very rough, and we gave them a broad range because they could go with any installer they wanted, and there was a pretty broad price range to choose from.
Yeah. And so how long did you do that for?
I was doing that probably from 2006 to about 2011, 12.
Okay. So you did that for quite a while.
Yeah.
And that was doing the solar, and then you said there was an energy auditing piece as well to that?
It was, I got trained as a home inspector.
Okay.
Didn't really do a whole lot with that.
Sure.
You had to really know people and get in with.
You were an independent home inspector?
Right.
Yeah. So it's a lot of networking and marketing and everything to keep that moving forward. You don't get a lot of repeat business, I suppose. Once somebody buys their home, you do the inspection, they love you, and then that's it.
Yeah, exactly.
Got it. Okay. And so you did that from 2006 to 2012.
Yeah, so right around 2010, 11, I could see the writing on the wall where the site assessments were dwindling. The solar work was shifting more towards salespeople doing the upfront assessments, and then the electricians doing the more technical stuff on the back end, kind of how it is today.
Yeah.
So I got trained as a BPI energy auditor, or building analyst, as they call it.
Yeah.
And jumped right in with focus on energy. And also the city of Milwaukee had their own program where they were actually paying up front for the bulk of the assessment itself, the energy audit.
Yeah.
And then they also had some incentives for people to move forward.
Got it.
So,
were you an independent contractor in that role as well?
Yes.
Got it. Okay. So you've done a lot working for yourself throughout the years, and so you got your building envelope, building analyst certification around that 2010, 2011 timeframe. Did you work for any organizations as an in-house auditor or assessor as well, or
just one? For a year and a half, I worked with a weatherization agency called La Casa de Esperanza, out of Waukesha, Wisconsin.
I could not say that again. Yeah. Okay. And so you worked for them, and you were doing kind of similar to like the weatherization assistance program type stuff. You'd go in, assess the home, and would you then create the scope of works and things like that from there as well?
Yeah, exactly. And there was energy modeling in there as well.
Okay, gotcha. What kind of energy modeling software were you using at that time? Do you recall?
Yeah, it's called the National Energy Audit Tool, or NATE.
NATE, okay.
Sorry, NEAT.
NEAT, okay, got it. Yes, I've heard of that acronym. Very cool. And so then you were there up until you came to Greenlink. Is that kind of the transition that you made there?
No, I took a detour for a while there.
Got it. Okay.
Doing other lines of work.
Outside of the energy industry.
Yeah.
So, I mean, you had a decade or so, or maybe more experience at that time. Then you kind of stepped out for a little bit and then eventually came over to Greenlink. And how long have you been with us now at Greenlink?
2 years.
2 years, yeah, that's what I was thinking. Okay. And you've definitely came in and added a ton of value to what we were doing prior to you being at Greenlink. You know, we had a couple different entry-level auditors, and then I was primarily going out and doing a lot of that. And then obviously we had Noah. Noah's, a pretty experienced energy auditor as well. But you came in and really filled a role and a need that we had, and that's allowed us to dig in further into the programs, the utility-funded programs. And at this point, you really focus on NICOR and ComEd's energy retrofit program. You say that's the bulk of your focus now?
Yeah.
Yeah. And what does it look like in that role? Maybe you could just kind of share with us, from the front end, going out, maybe doing the assessments, and then through even maybe touch on some of the administrative stuff, because it's surprising to me, even still being in it, and then probably to a lot of other folks, the amount of administrative effort it takes to push these projects through the programs. There's a lot of tracking and data and analytics that go into it. But what does that look like for you on a project?
Yeah, so I basically take the project from start to finish.
Yep.
The first step being I go out to visit the customer in their home, go through the house, do a thorough inspection top to bottom. I look at the attic, the furnace, water heater, the basement itself,
Yep.
and some things throughout the living space where they could save energy,
Sure.
whether it's light bulbs or health and safety issues like bathroom exhaust fans.
Yeah.
And once that's done, I have to write up the notes. I have to calculate all the areas of any parts of the house that we're going to
Sure.
treat one way or another.
Yep.
Calculate the volume of the house, because part of the assessment itself is a blower door test. And that's kind of one key item where we measure how drafty is the house,
Right.
how much air leakage is there. So you get a number out of the equipment, but then you have to relate it to the size of the house. So I have to do some math,
Yep.
calculate the volume of the house.
Sure.
And that might be it might be really straightforward if it's a rectangle, a ranch
A lot
house.
easier then, right?
But sometimes if it's a Cape Cod, there might be strange angles and
Dormers and angles. And
a lot of geometry to do.
I was just going to say a lot of geometry, a lot of math involved in what you're doing.
Right. So I sketch that up to help me visualize it and get the
Sure.
right numbers. And then after that, there might be some questions because I run into in these older homes, I run into a lot of challenging situations where sometimes a particular aspect of the house prevents us from doing the air sealing or venting the dryer correctly or things like that.
Sure.
We might run into all kinds of challenges. We have to make sure that everything's up to code. Anything that we touch, we can't just leave it the way it was if it was not up to code.
Sure, especially on the health and safety side too. That's even maybe a little outside of the code. I'd say in addition to maybe, right? Because you got the code making sure the wiring is landed right or connected in junction boxes and all the standard code items. But then you've got that health and safety aspect, which in some cases can cause us to not be able to even move forward on a project. If you have maybe like vermiculite in an attic is one of those cases. What are some of the other health and safety things that you see? And then maybe somebody listening to this episode as a homeowner might look at their home and say, maybe that might be something I should, have somebody out to look at further. What are some of the things that come to your mind?
Sure. So things like you mentioned open junction boxes, vermiculite, which is known to contain asbestos in many cases. But also things like pipe wrap that's also asbestos
Contains
containing.
asbestos in it, yeah.
It might be on pipes from a boiler, or it might even be on really old ductwork.
Sure.
If it's crumbling at all, that's when you have to do
really
something about it.
examine and be aware of what might need to be done to correct that.
Yeah,
in that
that
case.
can get in the air. It can be a problem for the lungs.
Absolutely.
But also things like excessive moisture. If I see mold forming on the walls and ceilings,
Sure.
Sometimes I'll see it in crawl spaces or basements. That can be an issue. Things like spaces that are vented that shouldn't be, like crawl spaces and basements.
That's a big one. Yeah.
Because we don't want that outside cold air coming in and cooling everything off.
Thank goodness for building science. I mean, there was a time when that was intentionally done, and there's almost like a mixture of trying to insulate yet trying to ventilate. And obviously we see that is not ideal. We know that now in our climate zone. When you talk about the moisture side, people will see that in the form of mold, mildew on, maybe ceilings in a bathroom is a real common area. And you get into bath fans from there, which is, I think, an interesting topic. what are some of the things that you do? You identify this, but then how do you quantify and analyze further what's needed for the bath fan, and what are the steps to make sure that that bathroom is well ventilated?
Well, we have to make sure it's strong enough. So it's got to move the right amount of air. So at least 50 cubic feet per minute.
50 CFM minimum.
Right, right. And you'll see, when you go to the hardware store and buy a bath fan, it'll be rated for a certain CFM.
Yep.
But once you hook it up, that could go down.
Yeah,
because
we see that a lot, unfortunately.
You might have kinked the ductwork.
Yeah, yeah.
You might be blocking it somehow. You do have to exhaust it correctly to the outside. You got to make sure that humid air doesn't just sit in the attic.
Right.
You got to make sure to take it outside, and the best way to do that is upward through the roof.
Get it straight. Straight from the bathroom, sucking that air, getting it out of the house. And it's an important caveat that you made there, because through the years, again, different generations of builders and building science principles, venting the bath fans into the attic at one point was very, very common. And they would just dump them in there, maybe not even vent them at all. It's just the bath fan's there and it's, dumping into the attic. Or what we've seen too a lot is when they run the termination down to a soffit. I always find that to be problematic. And in some cases you have to, or you don't have great options otherwise, maybe for whatever reason, a slate roof or odd construction of the home. But when you're venting that moist air into the soffit area, you're also using that soffit as the intake ventilation for the attic. And I don't know if I've told you the story, but in the early days of Greenlink, I was doing an assessment. It was what I call like a McMansion. I was up in the Roscoe, Rockton area, huge house, lots of odd shapes and geometry, like you were saying. And it was the middle of January or February when I was assessing this attic. They actually had called because of moisture problems, which I think is something we should dig into as well. But so I'm up there and I'm in the attic and I see the rafter cavities going down into the eaves and the soffits. And one of them is perfectly clear. It's just, proper plywood, nothing wrong, nothing out of the ordinary. But the two on the side of that both had a wind pattern of frozen moisture swirling, and I could see the air movement. It was actually really fascinating to see the air movement, how it was bringing that moisture back in. So it was just a cyclical situation that was happening. They're creating moisture, they're dumping it out, bringing it back in, thawing out, repeat cycle. And so that's a really big one, an underrated thing, I would say, not necessarily in building science, but just in the remodeling construction industries. I don't know that we often see even in new construction bath fans vented as ideal as we'd like to see. At least I haven't. It could be a house from 2010, 2015, and they're taking that method where they're dumping it into the soffits.
Right, or they may not be insulating the ductwork.
That's a good point as well. Yeah, you're
because
taking that
winter,
hot air, right?
Yeah. It'll condense in winter.
Yeah.
That duct is cold. It's made of metal.
Yeah.
And it could just drip back down into your bathroom.
Right, dripping into the bathroom, or in some cases dripping onto the drywall ceiling. Mm-hmm. I think, as we talk about different ways that a homeowner could identify potential building performance issues, that's one of the big ones right there. Look for the signs of moisture. And homeowner might not know who to call. We've worked with a lot of roofing contractors through the years, where we say, hey, you're probably going to get this call in the springtime or in the late winter when we start to see the freeze thaw, reoccurring cycles. And what that is the frost that has built up on the roof decking in the coldest parts of winter is now thawing out and it's dripping back down, and you'll see little drops of moisture all over the drywall ceiling.
I'll have to say that's actually part of why I ended up as an energy auditor. Really? I was living in a house where I hadn't gone into the attic because I had little babies at the time. Mm-hmm. And so I trusted the home inspector to inspect it for me. Yeah. He didn't notice that the bath fan wasn't vented out.
Really?
And I was starting to get mold forming on the corners of my ceilings inside the house in the living room.
So you've been in that spot and you've gone through it. And how did you end up identifying? How do you work through that? So, you started to see these rings. Do you recall what that process was to
Well, I was thinking about getting an energy audit anyway. I was thinking about it. I had only been in that house for maybe a year, not even.
Sure.
So my thought process was, I can't really do solar. There's a little too much shade, but let's see what we can do on the energy efficiency side. Yeah. So I was going to call somebody in anyway. But with that situation, I picked the guy that had the best story to tell about improving those kind of issues with the moisture. Yeah. So I hired him. He was a little more expensive, but he gave me a thorough education. Yeah. And told me exactly the steps I needed to do, and I went ahead and did it. It solved the problem.
That was the third-party inspector that you hired?
Yeah.
And then you hired a contractor and said, hey, here's what I need done here. and they started to work through it and get everything taken care of for you.
Yeah, I actually needed to use, I think, 3 different contractors, but
really,
either way, I got it all done.
That's interesting to hear that you had to use 3 different contractors, maybe 4, including the energy auditor, I would suppose, right? Some folks have talked to me and said, hey, you know, where did the idea of Greenlink and why do you guys do so many different things? Why do you have HVAC, solar, and the envelope or weatherization piece? And I tell people, you know, in my early days when I was working in the Illinois Weatherization Assistance Program as a technician for another company, I quickly realized, I was like, wow, so this customer just went and got new windows and doors put in, and they had somebody out to do, you know, maybe a furnace or air conditioner, and then they're calling somebody else to maybe do installation, but the installation guy didn't air seal or didn't ventilate. And I'm seeing like the homeowners left to try to piece this all together, not too different from your experience. And I thought it's really important that a homeowner or customer can work with one company that can take that holistic view and help guide them and share the information, whether or not you sell them solar and weatherization. It doesn't matter. It's just the point that the customer has the opportunity to get that centralized source of information based on what they're looking to accomplish.
And that is so valuable because in my experience, I actually ended up paying for the installation twice.
Really?
Because I did things in the wrong order. I didn't follow the steps that the
but
guy
you wouldn't
gave.
know as a homeowner.
No,
right?
I had to. I didn't realize I had to get the roof deck cleaned off because it was moldy first before putting in the clean insulation. They had to, spray that first, and that would have contaminated the new insulation.
That's unfortunate.
So I had to get it removed again.
Yeah. Wow. So you removed the insulation twice from there? That is a very expensive and an unfortunate learning lesson. Yeah. But from there, was it pretty quickly after that experience when you started to move towards the energy efficiency industry, or was it years after?
Yeah. It took me a while to sort of beat on some doors to get into the Focus on Energy training cycle. So I think they were undergoing some changes in their schedule.
Okay. Yeah. Well, Focus on Energy has always been, from what I understand, kind of very forward thinking and kind of the tip of the spear, so to speak, at least, regionally. When I, first joined Focus on Energy, because obviously we're Illinois-based, Focus on Energy is out of Wisconsin. I'd say 5-6 years ago, maybe somewhere in that area, we started doing some work in southern Wisconsin areas, and I was very surprised at how advanced and how long that program's been around. It must have been around for decades now, right? Yeah. That's not something that you see in a lot of states, at least that I'm aware of. The advancement and the focus, no pun intended, that Wisconsin has put on energy and energy efficiency.
Yeah, it's been a very successful program. Every year they tell us how much energy was saved per dollar that the program has put out.
Okay.
And it's always been very successful, and people are really happy with it. They have a great system for connecting homeowners with contractors and consultants.
That's something I definitely noticed. And at one point, Focus on Energy, they had it set up where very deliberately they would have third-party auditors and then the contractors, and they weren't really hip to the idea. Maybe it was totally not allowed even, I don't know, for the contractor and the auditor to be a part of the same organization. Is that true?
Yeah, until about 7-8 years ago, maybe 10 years ago, that was considered conflict of interest.
Yeah.
Then they had a change of management with Focus on Energy. A different contractor came in to manage the program, and they had a different view of it.
Okay.
They had worked in other states like New York where that wasn't really how things were viewed.
Yeah.
And so they actually encouraged the energy auditors to either work for or subcontract for the contractors.
Okay, got it. Yeah, and I can see both sides of that coin. I when a customer through the years, I've always had the same answer to this question. Somebody will say, okay, well, if I go forward with this proposal and I make these energy efficiency upgrades to my home, what are the annual savings that I can expect to see? And I'm not saying it's wrong if a contractor does try to give those projections. Greenlink does not do that because I think that's when you start to cross the line, and it's so difficult to quantify those savings, in my opinion. I know there are lots of softwares and the programs that do that. But that feels tough. You tell somebody, hey, you're going to save $450 a year, and it ends up being $375. Or did you give them the wrong information? Would they have gone forward with the project? Now they're dissatisfied, and so that's where if somebody wants modeling and the financial side and the savings, I will typically tell them, hey, you should talk to a third-party auditor. Let them give you that information. But it is important for the contractor to have the ability to diagnose, run blower doors, do energy audits. Otherwise, how well can they do their job? And to have somebody in-house like you do and Tyler and Noah to help QA, QC the technicians, just additional accountability to try to make sure we're doing the best that we can do for a customer.
Right, exactly. You want to have a way to quantify before and after. How much did we improve the house?
Yeah.
Not so much in terms of dollars saved, but in terms of the things that are measurable, the air leakage of the house,
great point. Yeah.
The bath fan effectiveness.
Yeah.
Things like that.
So that kind of brings me to a thought, and maybe something to explore a little bit together, is like the energy audit side. So we've touched on, a blower door and what that does. That measures the air infiltration in a home. Beyond that, what are some of the key aspects of an energy audit and some of the importance behind them, the value that you get from it?
Right. So I'm actually up there crawling around the attic, looking for as many issues as I can find.
Yep.
As many, so we don't have surprises down the road.
Right.
Because if I just popped my head in through the attic scuttle and looked around, I wouldn't find half the stuff that I'd find.
You would definitely have
crawling
surprises down the road for sure.
Yeah, and looking at things like the age of the furnace, does that need to be looked at by an HVAC technician?
Yeah.
Looking at the rim joists down in the basement, are they leaky? Are they insulated properly? A lot of times you'll see fiberglass bat just stuffed in there, not very neatly. It's not nearly as effective when it's crushed as it is when it's nice and flat.
And that's fiberglass, the product of fiberglass itself, right?
Yeah.
It needs to trap pockets of air in order to give the thermal barrier. That's essentially the way that it functions. And so when it's crushed and compressed, you lose most of the effective R value of that product.
Right. That and the fact that if it's not enclosed on all six sides of the rectangle, the volume of the enclosure, it's not going to be as effective because you have air movement through it.
Yeah. Which is interesting because I see when, like some dense packs that we've done in days and some remodeling that we may have done, there used to be these fiberglass bats. You have a 3.5 inch or maybe old school 4-inch depth wall cavity. And the bats that they would put in there, I don't know if they shrunk or if that's the way they just were, but they would only be like 2-inch bats. And then you would have another 1.5 or 2 inches of space. Have you seen that before?
Yeah, that was done in the 50s, 60s, 70s. And that's all the insulation they thought they needed. They didn't realize they needed to fill the cavity. Right.
So they said, this is good enough. We got some insulation in there and we're good.
Yeah.
And the unfortunate part about that, when we talk about the insulation piece, but just as important in the building science industry is the air sealing side. In some cases, maybe more important. But the air sealing is critical. There's an analogy that I think Chandler used to use. I heard it from somebody. But if you imagine yourself walking outside in the middle of winter and you have this giant ball of cotton and you're inside of it, and you walk outside in the winter in a blizzard, you are still going to freeze to death if you're outside. That's just the way it is.
That's a great analogy. I love it.
And then now if you get some Gore-Tex and wrap around that so you have that barrier to the airflow with all that cotton, now you've got an air barrier and a thermal barrier. Now you're good to go, and you can probably roll through that blizzard okay. Yeah. And our houses are very similar to that.
Sure.
So talking about that air barrier, how about some of the mechanical side of this? Because you talked about, you're looking at furnaces now. When you're doing these audits, I always have looked at furnaces, but now at Greenlink, we have this HVAC division, and so we're able to bring that additional value to a customer. But specifically, I'm interested in the CAS side of an energy audit, the combustion appliance zone.
Right. So that's it's critical for that to be constructed correctly so that we exhaust everything out to the outside that needs to be. Anything that burns fuel is going to generate carbon monoxide, and that's obviously a health hazard.
Yep.
It's known as sort of a silent killer. You don't smell it, you don't see it. Hopefully you have a carbon monoxide detector in your house that'll sound an alarm, but just in case that fails, we do not want to have anything bringing carbon monoxide into the house. And so what can happen is when we make a house tighter, less drafty, that the air pressures change in the house, the interplay of the air pressures between the combustion appliance zone and the rest of the house. And that can cause the water heater, that's usually the appliance that's the one that's most likely to fail. Yeah. It needs air pressure to be balanced out correctly so that it can vent up the chimney or up the vent. And sometimes it goes backwards. Sure. Because you have things sucking on the house like a dryer or a kitchen range hood.
Yep.
Those things suck air out of the house and they can pull air down the chimney so strongly that the water heater can't even overcome that with its hot exhaust.
And then you're spilling carbon dioxide back into the house in that case.
Right. And so that's our safety hazard that we've tried and prevent. Sometimes we have to do unusual things to mitigate that. Sometimes it's as simple as installing a chimney liner.
Yep.
Other times we have to reroute the venting. Other times we have to replace the whole water heater with a power vented one.
Yeah.
Depending on the configuration of things in the mechanical room.
Yep. So like combustion air is really what's being affected. You know, when that water heater kicks on and it's creating heat, it will eventually start to create that draft for itself, typically really quickly, like within 60 seconds or less, right? Is that typically what you would find?
Yeah. And we like to see it within 2 minutes. That's the test criteria.
Got it. So within 2 minutes, you want to see that draft established. But when air is leaving the home, air has to be replaced. Otherwise, you start to create a negative pressure in that house. And a natural drafting appliance won't overcome a significant negative pressure against it. And that's where the combustion air is necessary. And like you said, a chimney liner, that's actually something we should dig into because we've seen that a lot through the years. I think the industry is much more advanced on it. It's code now. But for a while, I would go into homes and I would see where somebody had replaced an 80% furnace. So that was tying into a common flue with the water heater. And that common flue, as we both know, is designed based on the amount of BTUs that are going into it. And so you might have a 6-inch common flue that's being shared with a 5-inch flue from the furnace and a 3-inch flue from the water heater because you had 100,000 BTUs and you had 40 or 50,000 BTUs from this water heater. Well, now you've only got 50,000 BTUs. And those BTUs are trying to draft up into that common flue. They start to separate and the gases cool down. You don't gain the velocity to get that out of the house. And so that chimney liner is what's important to maintain that when you abandon, or we call it orphan water heater.
Yeah,
is that the term? An orphan water heater. It can be something that I'd say as a homeowner, you should watch out for that. Kind of be aware. I'm not saying that if you have an orphan water heater, meaning you have a high efficiency furnace that used to be an 80%, or that you have a problem, but you just want to, as a point of awareness, as a homeowner, you want to watch out for that. And some of the visual signs, what's something that a homeowner might be able to see to say, hey, I may have a drafting issue here. Do you have any tips or tricks?
Yeah, so definitely if you see any scorch marks at the bottom of the water heater, that's a strong indicator that there's a bad problem.
Yeah.
Another thing that's a little more subtle is if you have pipe insulation right next to the venting of the water heater and it's melted.
Okay.
That's a sign that the hot exhaust has been coming back into the house.
Sure. Right around the grommets where the water lines are coming in and out, right?
Exactly.
Yeah. And that's something I see that quite a bit. Yeah. You can see that where those rubber grommets, you get the blue and the red rings and they're melted a little bit. Something else that I've seen and I kind of look for is the condensation is very acidic. Is it acidic, right?
Yeah. So then it causes corrosion of the ductwork of the flue, and it crumbles. So I see little crumbs on top of the water heater.
That could be another sign that you're having a drafting issue. Yeah, that's a great point. And so, what tools do you use? What's the process to measure the flow or the draft rather of the water heater or of a combustion appliance in general?
So we use what's called a manometer. That's a device that measures pressure and actually measures pressure differences between whatever it is that you're focused on and the outside world.
Sure.
So I run a hose from the mechanical room out to the outside, usually through a back door or front door.
Yeah.
And I compare the pressures. First, just within the room itself and under different conditions. So I add things that make it worse and worse for the mechanical room.
Which are those exhaust appliances, right?
So, the exhaust fans in the bathroom, kitchen, the dryer.
Yeah.
I'll close doors to sort of make the air volume smaller that all those things are sucking on.
Right.
And then there's the furnace. I turn on the furnace fan, and sometimes if there's like a central return, that could be sucking on the mechanical room and blowing air into the rooms.
Yeah.
So that could cause more negative pressure in the combustion appliance zone.
And that test is our worst case depressurization. Is that what we call that, right?
Right. So we identify which condition is the worst of those.
Yeah. How do we try to make this thing fail, basically?
Right. Exactly.
Yeah. Yeah.
And then I turn on the water heater under those worst conditions, whichever gives me the most negative pressure on my manometer.
And that's when you're going to fire it up.
Right.
And see, okay, now I know what my worst case depressurization is. Maybe it's negative 4.3 pascals. And so you've identified that, and I say, okay, now I'm going to turn this on, and I'm going to now measure the draft of
we don't even measure the draft anymore. It's
Okay.
just a pass-fail if it spills or not.
Got it. Okay.
Within those 2 minutes.
So as part of the evolution and different generations of training, there was a time when we would put a probe from the manometer into the flue, and we would see what's the velocity of that draft, or it wasn't really velocity, it was pressure. Yeah, the pressure of that draft. And I always thought that was neat to kind of see that. But again, if you go with, like, say, a high efficiency water heater and you're a closed combustion appliance, now that becomes almost a non-issue. At least, from the furnace, closed combustion, if it's a 90%er, and then the water heater, closed combustion, you don't have those same concerns about backdrafting at that point. Is that correct?
Right, exactly, because you have an actual fan on top of the water heater blowing the air, the exhaust out.
Yeah, you're bringing the pressure and forcing it, saying you're going out of the house one way or the other.
Right.
Yeah, that's a good thing to be aware of. And, so you have the high efficiency aspect of those appliances, but then you also have the health and safety addition that comes with that as well. And, now as we, advance even further and start looking more into the electrification world, when you have, say like an air source heat pump, you have no combustion happening within that unit unless you have an, auxiliary, natural gas aspect to that, which can be done, a dual fuel hybrid. And the same thing for the water heaters. When you have these heat pump water heaters, they have electric resistance as an auxiliary or backup on those. You have no combustion happening at that particular area. So, staying in the vein of the energy audits, I'm curious to hear a little bit about, some of the other areas. So you talked about the attic. We've talked about kind of the basement area with the rim joists and the appliances. But how about like the infrared inspections? That's something that people see a lot, and the visual of an infrared catches folks' attention. What are some of the things that you see? How do you use that tool, and what are the values?
Right, that's a highly valuable tool in my work because it allows me to see the contrast between hot and cold.
Sure.
It can measure specific temperatures as well. If I really want to dig into something, I can find out what temperature something is. But usually, it's just the contrast that shows me the whole story. First, I can identify areas of missing insulation.
Yeah.
And when I'm running the blower door, I can have
It's very fascinating.
a view, a picture of streams of air coming in.
I always love to see that. I mean, on the pre, not the post, obviously.
Right.
But that's always really cool when you see that cold air, and the more contrast you have, the better, right? And if it's a really cold winter day and they're heating their house, that's a great time to try to run an infrared camera. Obviously, it's less ideal when it's 70 degrees outside and your house is 70 and you got the windows open.
And it's cloudy.
And it's cloudy. Yeah.
Because the attic will heat up nicely if it's sunny out, so that
Sure.
provides some contrast. I can see hot air streaming in through, let's say, the can lights or the top plates.
Yeah. Can lights, that's another great point too. And as a homeowner, things to look at. Can lights are essentially 6-inch holes in your ceiling, and they're allowing airflow back and forth from the attic space. And when we look at, again, the air sealing side, we don't want to allow that warm, moist air to travel up into the attic space. Same kind of vein as the bath fans, really. We're trying to control moisture in the home. We're trying to control the airflow. And when your home is letting that warm air out of the house, now your house has to breathe and replace that air that it just lost. It becomes under pressure, and that's when you can start to see more air infiltration, maybe at the rim joist or the lower sections of the house. Maybe you could talk to us a little bit about that, Barb, the pressure boundaries of a house.
Right. So one thing that people oftentimes aren't aware of is the fact that there are pressures naturally occurring in the house. What happens, let's say in the wintertime, you're heating your house, the air in the house gets warmer, it gets lighter and more buoyant, it wants to go upward. So it's actually pushing on the ceiling.
Right.
And so as a homeowner, you don't think that a teeny tiny little gap between your light fixture and the ceiling drywall is going to make a difference, but it does because it's actually pressing. The air is pressing on the ceiling. It's trying to get out. It's looking for a way to get out.
Yeah.
And so any little opening is fair game.
Yeah. Yeah. That's really interesting. Maybe another way to think about that too is like if you inverted that, you flip the house upside down and you filled it with water. Now you've got this pressure. Now maybe it gives a visual of how you can see that water is going to find its way out because it's under pressure and it's going to find those cracks and seep through. And the airflow is working in a similar way in the wintertime when you're in the heating season.
Exactly.
And then in the cooling season, similarly, right?
Yeah, but in reverse.
In reverse.
So in the cooling season, you've got hot air in the attic. The cool air wants to go down.
Right.
You're paying to cool the air.
Yeah.
And so it's going to find the lower areas, the gaps on the lower part of the house to escape from.
Right. And then you're potentially allowing that warmer air from the attic then? Does that create that same cycle too where it's going to pull in the warm air?
It's going to pull in. And oftentimes that's why a second floor on a 2-story house will be warmer than the first floor.
Yep. Yep. You're just letting that air in there, obviously unintentionally, but I think that's important to note. And, earlier on, I talked a little bit about the age of a home. A lot of customers I've had through the years, they have a problem, they call and I start to say, okay, yeah, I know exactly what's going on. You have an air infiltration issue or the bath fan venting, whatever the case is. And they're like, well, but this house is new. It's only a 5-year-old home. And although that shouldn't be the case, I always tell people the age of your home does not preclude you from having less than ideal air barriers or thermal boundaries within the home, unless that builder was very, very intentional and had blower door tests ran and they were done comprehensively and really paid attention to it. At this point now, blower doors are code in a lot of areas for new construction. I know you were going out and doing a lot of blower door tests, but the builder still has to have a desire and intent to want to really tighten that up. Or if they're just checking a box, you're not going to get that same value that you could otherwise with the intentionality behind it.
Exactly. And, even if you have a general contractor managing all the different trades, the tradespeople aren't really communicating with each other all the time 100%.
Yeah. Yep.
You might have somebody cutting a hole and not telling the installation contractors that, hey, you need to seal this back up.
Yep. Or they came in after the installation contractors, right? And they had to move a pipe or they had an issue and now you've got a 3-inch hole for a 2-inch pipe and you've got that ring around it letting in all the daylight. That is unfortunately not too uncommon. So yeah, it's an important thing and a good point of awareness, again, for everybody to understand the different ins and outs of how the energy audits work, what are the things that we're looking for, and then also the different ways that a homeowner could identify some of those issues. Well, Barb, I appreciate your time today. This was a really good conversation. I hope it's helpful for some of the folks that might be listening to better understand your home and different pathways to address some issues that you may identify. So we will catch you all in the next one.